All right. Hi, everyone. I'm Daniel, Business Operations Manager and Marketing Lead at Synera, and today's host for this Thought Leadership webinar. Thank you all for joining us in such big numbers. And just a short technical thing, feel free to use the Q&A function, and we'll come back to your questions. Speaking of today, in today's competitive landscapes, AI agents have already reshaped industries like legal, like customer service, like finance. But when it then comes to engineering, their true potential feels like just starting to unfold. And at the same time, engineering organizations are under growing pressure to reduce costs, to move faster, still meet the very high standards for quality and innovation. And we see companies today trying to meet these challenges in many different ways through, for example, productivity or efficiency projects, through hiring to get more done, to firing to save costs. So many different approaches. And these traditional approaches, they are in many cases hitting their limits, as they are heavy on manual effort and scale only through increasing headcount. So the cost scale barrier that you can see here on your screens. In this conversation today, we will explore how AI agents can be one of the ways, one solution to directly address these key challenges facing engineering organizations today, and how the companies of the speakers that you see on the screen here today that are on the software, on the infrastructure, consultancy, and of course on the user side, how they are enabling and utilizing this shift to break the cost scale barrier of many of the current approaches. We thought how to make this as valuable as possible to you in the audience. And so we've gathered an amazing group of experts here. And for me, I always find it very important to know who I'm listening to. So for their introduction, I'll give you a bit of background for each of them. And today I'm starting with Ryan McClelland from NASA. From a young age, Ryan has been captivated by futurism and technology, aspiring to contribute to a brighter future. As a research engineer in NASA Goddard Space Flight Center's Instrument, Systems, and Technology Division, he pursues the development and infusion of digital engineering technologies for spaceflight missions. Ryan is particularly excited about the potential of artificial intelligence, virtual reality, generative design, and digital manufacturing to accelerate space systems development. Ryan has played a significant role in various flight missions, including designs currently on orbit aboard the Hubble Space Telescope and the International Space Station. Recently, he served as the Roman Space Telescope Instrument Carrier Manager, and he holds a Bachelor's of Science in Mechanical Engineering, summa cum laude, from the University of Maryland. Hi, Ryan. Nice to have you with us.
Hey.
Next, we have Ferdinand Schockenhoff with us today. Ferdinand, Senior Manager at Capgemini Invent, is responsible for automotive product development 2030 plus, including AI at automotive engineering. In his role, he supports clients from the automotive industry in their transformation to modern agent-based product development. In addition to consulting projects, his knowledge is based on a PhD in product development processes. Great to have you, Ferdinand.
Hi.
Then, next we have Sam Bidlan joining us from Amazon Web Services. He's a specialist solutions architect with the Advanced Computing Emerging Technologies team at AWS. He specializes in agentic AI and multi-agent systems, focusing on applications that solve complex business challenges at the intersection with high-performance computing and simulation. Sam has 13 years of experience developing computational solutions across research, science, and financial services, bringing a multidisciplinary perspective to emerging AI applications. Sam received his PhD in geophysics from Stanford University, where he focused on large-scale earthquake simulations. His current work explores how AI agents can transform engineering and R&D processes by simulating human collaboration and breaking down traditional workflow barriers. Thanks for being here today, Sam.
Great to be with you, Dan.
Thanks. And completing the round, we have Moritz Meyer. the co-founder and managing director of Synera. He launched his first company at 16, driven by a passion for tech and entrepreneurship. His path through research and consulting led him to a core question that still drives his work. How can engineers work smarter through automation, not just faster? With a PhD in product development and deep expertise in generative design, additive manufacturing, and process automation, he's now building with Synera towards a vision of Jarvis for engineers, AI agents that support technical teams and free up space for real innovation. His core belief, technology should adapt to people, not the other way around. Hi, Moritz.
Hello.
All right, that's a good introduction. Now you know who's talking to you. And now that we've met our speakers, let's get into the conversation. And I want to pose a key opening question to Ferdinand, because we see a lot of development in generative AI in general, and starting at the end of last year, especially on agents or agentic AI, we see a huge amount of hype. Ferdinand, how do you see the overall trend and its impact on R&D in the near future?
Yeah, thanks for this question, Daniel. Every R&D organization is under pressure in terms of cost saving, time to market, quality standards, and product complexity. And AI agents will be a puzzle to solve these issues. Why they can do that? Because they can help to shorten development cycles, to shorten time for specific tasks. I guess we'll discuss about these tasks later. But with that, the R&D organizations can handle their product complexity in a shorter time. Furthermore, you can standardize processes and standard processes, and engineers will have more time for innovative work.
Thanks, Ferdinand. So fast and time to development, maybe let me ask this to Ryan. What are the key challenges that you face in engineering or in your organization today?
Yeah, so NASA's missions are continually more challenging, right? We can't go back and do the same things over again. So we have missions like the Habitable Worlds Observatory that is going to look for habitable worlds around other suns, and the Dragonfly mission, which is going to fly a drone on Titan. So those things are really challenging, but the budgets are about the same, right? So when you have more challenging missions with the same budget, you need to develop better ways to do things. And I really see AI agents as being something to help solve this challenge of helping us, sort of break what some engineers call the triple constraint, which is to be faster, better, and cheaper by having these, AI agents take over a lot of the tasks and sort of encode a lot of the institutional knowledge that we've developed on how we build reliable missions.
So how do you see the AI agents? What's their role in addressing these challenges?
Yeah, so I see the agents being able to just help accelerate the iteration cycle. So, one of the challenges that we have is because these designs are so complex, it takes a really long time just to get to a first iteration. And if you've taken a long time to get to the first iteration, you're loath to sort of like go back and change things. And then you sort of can get stuck in a local minima, if you will. So AI agents, I think, are going to allow us to just iterate the design much more quickly and really explore the trade space of what our designs could be in a way that gets us into eventually a better solution.
Yeah, maybe to go more into the specific problems, Ferdinand, what specific problems in engineering would you like to see AI agents solve in the next few years? From your background in consultancy, what do you see in the market right now?
First of all, I think about the early development phase. Why I do that? There are a lot of target conflicts, like industrial design versus technique, functional versus geometrical requirements, and so on. And currently, a lot of stakeholders have to discuss these target conflicts. They do their typical exploration with a lot of stakeholders and need, I don't know, 3 to 4 months to discuss these target conflicts. And as Ryan described, with agentic AI, we have very short cycles to discuss these conflicts, and we will have the possibility to consider several concepts instead of one concept which is feasible. We have more solutions and can decide from a more informed basis.
So I'm hearing a lot of insights that it is all regarding human collaboration. Sam, what do you hope AI agents can achieve that current technologies or workflows cannot?
Yeah, I absolutely see it the same way. And, having recently collaborated with Synera on a multi-agent system for engineering workflows, yeah, definitely gained some practical insights on this topic. So I think the most exciting potential of AI agents is their ability to simulate collaborative human processes. So these technologies aren't meant to replace human expertise, but rather to augment their capabilities. So traditional technologies, traditional code development typically follow these fixed predetermined steps, where, what works for structured problems, but sometimes struggles to the complexity and the needed adaptability that are required in not a lot of real world challenges. So I see agents as tools that can support decision making about process flow rather than just executing those predefined steps. So this is fundamentally different than traditional automation because it introduces this level of, what I call assistive intelligence in how workflows unfold, with humans always providing that essential judgment and creativity on top. So in the engineering context that I've worked on with Synera, so one particularly promising application we explored was in complex processes that traditionally require multiple specialists or teams that are all working together. So in the real world, when these specialists aren't immediately available, or maybe they're distributed across time zones, projects sometimes can stall for days, maybe even weeks, waiting for those handoffs between the teams. So what I believe is that AI agents and multi-agent systems could really potentially support these collaborative workflows. So providing at least a starting point from which human teams can build off of and then can refine and improve. So I think that these approaches, they could lead to really significant productivity improvements by reducing wait times and allowing for faster iteration on ideas. And again, the goal isn't to replace specialists, but to amplify what they can accomplish. So spending less time on coordination, routine calculations, and more time on creative problem solving and innovation, which is what we all want. So it's still really early days. We're just beginning to really explore what's possible, especially in that frontier realm of multi-agent systems. But I really think that the potential to completely transform how teams collaborate, especially in technical fields, is significant.
You use the term transform. Transformations are huge things and they take a long time. Engineering has gone through many of these kind of transformations in the past and will go through many transformations in the future. For example, from paper drafting to 2D computer drafting, 3D drafting, 3D modeling. Moritz, do you think agents will usher in this next transformation?
Yeah, I guess we can think about this like it is actually. So from 2D, actually, when you remember the times when you do two-dimensional drawings, actually the tool that people had was kind of a paper and a pen, and they kind of like draw. And like the transition to 3D, let's take the CAD example, for example, or parametric CAD. There have been new tools. It has been like the software, the computer, like software tools like CATIA or NX has become, let's say, the tool where actually humans then maybe with a mouse or a keyboard interact with. And the capabilities have gone up by, I know, 100x in terms of two-dimensional drawing to really being able to shape 3D geometries with the help of a computer. And you can see about like the complexity which increases also. If you have a look at let's say, a full Airbus design, for example, in the 3D CAD world, all of these informations are in there. So the complexity just becomes insanely. And for me, we are at the same transition point at the moment when we talk about AI agents, because there's a fundamental shift in actually the user interface that we as humans actually interact with these systems. So with AI agents, we don't longer anymore go with mouse and keyboard and interact with the software. it becomes more a natural language interaction with an intelligent system that we see. So some of you maybe have also followed like the latest transitions into the interfaces that are popping up, like MCP or agent-to-agent communications at the moment. So we really see that the software, the tool landscape is kind of transforming into being compatible to agent interactivity. And if you see this transition, which at the moment is going over the full software tool stack, I think this will have a similar impact, like maybe like SaaS or cloud application head to desktop world. And we will see tools or software tools in the future who are really made for agents. And like humans as us will no longer click with tools or keyboards and software along, but we kind of like interact with these intelligent systems just by language. And so the vision actually of having a Jarvis, maybe this is like too futuristic, but it's really going there at some point. And I definitely see these transitions happening similar like from 2D to 3D now also with agents.
Can you explain a bit for the audience members that might not be so familiar about multi-agent systems or how multi-agent systems work in engineering? Can you dig a bit deeper in that?
Absolutely. Let me maybe share a very first slide which shows the principle of an agent and theory. I guess most of you already have worked with large language models. So for example, ChatGPT, you have maybe get in touch with. So this is basically one piece of an agent, the large language model itself, which then actually gives the intelligence into the agent system. But there's two more recipes or like ingredients that you need for an agent. It's the so-called orchestration layer, which you need. So you could like give an agent a profile, or you can give it some goals or instruction. For example, please act as a injection molding expert and these kind of skills, so that you actually can prime the large language model in a kind of like a job or role definition. And then there is a very important ingredient for us engineers. It's the ability of an agent to call tools or workflows, as we call it at Synera. And these workflows could become engineering tools, like, for example, CAD constructions or simulations, or finding the maximum stress values, or generating a design then which fits on a mounting plate for a satellite or stuff like this. So an agent actually is the combination of an AI model and a deterministic tool which it actually executes. And this is super important for us engineers, having these two worlds combined in one. And if you then think about not only having one agent, but you can actually like think about multi-agent working together. We talk about multi-agent systems. And I kind of like to explain it like a little bit like an organigram, like multiple people working together in a human team. So you maybe have some managers, maybe you have some experts have tools. And as a team, they can do amazing stuff. And similar things can happen with multi-agent system if you couple multiple agents, multiple AI models together, that they can act as a team where every model has its specific expert knowledge and tools.
Thanks, Moritz. It's a huge technology, and the promise that it carries is especially huge. But when we look to the adoption of a technology such as this one inside of organizations, inside of R&D organizations, Ryan, what do you think are the key challenges in adopting this kind of technology for engineering? And maybe you can also give your thoughts at how they can be overcome, these challenges.
Yeah, I think one of the key challenges is connecting the subject matter expertise, the people that really know propulsion or structures or thermal, with the tools, and just changing the mindset where it's almost more like a software engineering approach to developing hardware. So I think finding and training those people is a real challenge. And I think we can overcome that sort of just by building up on the stack. I see that if you can get folks started using LLMs just in their daily life, just in their daily workflows, that's sort of a base layer of like, oh, this AI stuff, I should really start paying attention to it. And then if you can build on top of that, how to connect AI stuff with their subject matter expertise, that's where you really unlock the power of this approach.
Ferdinand, let's say we take this this unlocking mechanism that Ryan just described. How do you expect this integration of AI agents to impact the way engineering teams then collaborate or innovate?
Yeah, as Ryan said, I think data and expertise is the key. And honestly, unfortunately, most of the organizations are not AI agent ready. They have to do their homework first. What does that mean? They need the data. They need a traceability towards the data. They need workflow automation to build the current processes, or even better processes, system engineering processes with AI agent. And so, yeah, you need to have your data ready.
What kind of data in this case are you talking about, or what does ready mean?
Yeah, thanks for this question. AI agents can only use documented knowledge, including product data, process data, simulation data, and so on. So what that mean? Product data, traceability from the beginning to the end of the product development process, like a digital twin of the product. And with that data, you can train the AI agents and they can use the database. And furthermore, how can they work together? Yeah, you need your process documentation digital, and you have to automate your workflows like Synera do it. Like Synera do it, yes.
Mm-hmm. So for me, when we talk about adopting agents, about transforming engineering, then it is very necessary that we also talk about the infrastructure powering all of that. And Sam, we see current limitations of IT infrastructure, and maybe you can elaborate what these are when it comes to implementing AI agents in engineering. And maybe as a follow-up question, what does the infrastructure need to look like to fully support the deployment of AI agents?
Yeah. So from what I've observed in early implementations, one of the biggest infrastructure challenges is simply connecting agents to the specialized tools that engineers use every day. And I know that I think Ryan and Ferdinand both touched on this. So engineering environments, you often have multiple specialized systems, computer-aided design, CAD tools, simulation software, PLM, product lifecycle management systems weren't necessarily designed with API first thinking or agent interactions, for instance, in mind. So a mindset shift that I found particularly valuable is thinking in terms of parameterization. So for agents to effectively work with engineering tools, complex processes need to be packaged with standard parameterized interfaces. So essentially thinking of each engineering workflow as an API with clear inputs and clear outputs. So this kind of creates that foundational common language between agents and the tools that they're using. So this is where platforms like Synera can play a really important role. So by providing that way to model engineering workflows visually and then expose them through standardized interfaces, these automation platforms create that connective tissue between agents and the specialized engineering tools they need to access. So then the workflow automation approach that Synera has developed represents exactly this kind of parameterization thinking that helps bridge the gap. So packaging complex workflows and engineering processes as callable tools with these well-defined inputs and outputs. So importantly, though, I think the agent still needs contextual understanding of what all the parameters represent and are. So you need to, quote unquote, teach the agent what each parameter means, for instance, what ranges are reasonable, how to interpret those outputs in engineering terms. So for example, if you're working with, let's say, a fluid dynamic simulation, the agent needs to understand that certain output patterns might indicate design issues that require individual attention. So I think this combination, parameterized tools plus contextual understanding, really creates that foundation where agents can make intelligent decisions with specialized engineering tools that really handle those complex calculations in a trustworthy manner. But looking ahead, I think we'll see more engineering tools that are starting to be designed with these agent interactions in mind. So offering structured interfaces, as Moritz kind of pointed out, and better integration capabilities. But in the near term, I think organizations can still make progress by focusing on workflow automation to get started as that foundation, and by packaging those engineering processes as these parameterized workflows that agents can then later orchestrate.
Moritz, Sam talked about the tools and the context knowledge. What changes to the tool side do you expect in the next few years due to the adoption of agents?
I just recently talked to a big engineering software vendor, and what I guess everybody is kind of starting at the moment is the agentic function calling inside of a software. So maybe you remember this little office icon where you can just ask to and talk to, like this
Clippy.
Yeah, like Flippy, exactly. This is actually what at the moment is kind of like the low-hanging fruit for all of the software tools. So having co-pilots or agents inside of the software to kind of like call functions or macros. So this is definitely a shift that we see. And I think these trends will continue. So as Sam also mentioned, like AI API first is the thing if you want to interact with agents from a tool-to-tool connectivity. So once you actually have like get your software, your tool agent ready, then you need to make it compatible to other tools. And I think we will see more and more, let's say, interfaces, maybe starting with Python interfaces. This is definitely also happening already today. Most of the engineering tools already come with a Python interface, which definitely is a good step. And then it goes further to maybe an MCP interface or some kind of agentic interface, which will allow it in the future. So this is something which we see also happening already today. And then what I also can experience is something like, which is maybe going into the RPA environment. So maybe you have heard about OpenAI's operators. So this is kind of like somebody remote controlling the mouse and still clicking on the original user interface. So if this continues also not only for web interfaces, but also with desktop software, then also this could be a huge leverage for actually having classical desktop applications where an agent remote controls, let's say, the classic user interface of a mouse click or keyboard interface. So this might be, let's say, the workaround. And I'm really looking forward to the point in time where agents really can do this, because then actually you can just like push an agent to a, let's say, course of actually learning a software, learning how to use a software. Maybe you already have some documents or some academy files, and then actually can train an agent how to use a software. And this will really like speed up the agentic use of classical software tools without actually being the necessity of having an API first approach. But we're not there yet, but I definitely see this coming in the near future.
Mm-hmm. So using workarounds is not the best approach, I guess. But Sam, what are the most critical factors for having a best approach, for having successful implementation of AI agents in engineering or R&D environments?
Yeah, number one, I think the most critical, start small, right? So I'm a physicist by training. I'm sure that you have a lot of physicists maybe in the audience today. And we always learn you start by solving the one-dimensional problem before you move to the two-dimensional problem. And only then do you think about solving the 3D problem. Same principle applies here. If you're not working with agents and then you say, oh, I want to jump into a multi-agent system, you're probably going to have a bad time. So from my hands-on work, I always recommend if you're starting from zero, as I think Ferdinand mentioned earlier, you got to do your homework. You got to understand theoretically what these agents are, how they work, what they can and can't do. But I always recommend start with a single agent performing a discrete task with well-defined tools. So maybe that's analyzing requirement documents or helping generate test cases. So this is your 1D problem. Once that's working reliably, you can move on to that 2D problem, maybe by connecting multiple tools to that agent or introducing limited collaboration between two agents, which is a non-trivial problem to solve. And then only after mastering those simpler or intermediate scenarios should you really attempt complex multi-agent systems, for instance, with dynamic team interactions. So I think that this methodical approach really allows teams to build familiarity with how agents work, where they excel, and where they need guardrails. So another factor that I found essential is set proper expectations. So the technology is still maturing. There's a risk of both underestimating and overestimating what agents can and can't do. So in my project work, I've seen the most success when teams approach agent implementations as an augmentative tool to help automate these routine aspects of processes while maintaining human oversight for critical decisions. And finally, I really emphasize strong observability in any agent system, all the way from zero through development, even if you would push it into, say, more of a production environment. So being able to see the agent's reasoning process, so what information it's considering, how it's making decisions, sometimes this is called traces in the agent world, that really helps build trust and provides critical insights for improvement and debugging. So in engineering contests, especially where precision really matters, this transparency helps us understand when to trust agent outputs and when we should step in and apply our own expertise as humans.
Thanks, Sam. We have a question from the audience, from Arno, and let's see, wants to jump into that. As we talked a bit about APIs or operators, Arno asks, how do you see standards or standardization integrated into that?
Yeah, I can start with a little insight from of the recent project. So it was like a question, can we integrate, for example, standards in design, like design guidelines, for example, on how to actually create something like a good design or bad design? And we definitely see people applying these standards with the so-called retrieval augmented generation method. So just RAG in short, like a design guideline as a PDF, maybe giving it to the agent and just having it as a like a backlog or an information where he can just look up this information and try to, for example, then assess if a design matches the design guidelines. Now, this is one thing which I can experience, but I guess also like maybe Ryan, you have lots of standards at NASA. Maybe this is also a good question for you.
Sure. So I think there's two ways to look at this question. One is the engineering standards of your organization. And, in our case with like our text to structure work, it's hard coded. So which is great, because then when you have, junior people coming on board, their designs are going to meet standards because it's hard coded into the system. And then, of course, engineering standards can be used in a more intuitive way, if you bring them in with like RAG. But if they're a lot of standards can really just be written into your the tool the agent is using. But then there's also the standards of the agents talking to each other, which I think might be the question. So their APIs like REST APIs are a standard. MCP is the developing standard, though I understand it still doesn't have things like login and authentication. So yeah, I think the agent to agent standards are still rapidly developing, but MCP is kind of like exploding, but it has some weaknesses from what I understand.
Amazing. Thanks for your answers. Jumping back to what Sam said before, he was talking about different expectations in different companies or by different people. Moritz, you are talking to a lot of different companies about this topic. What are the expectations that you have discovered?
I guess talking to different personas, I would say especially upper management has huge expectations about this, because if you think about just like agents, it's very easy to think that they can do everything which engineering and R&D does at the moment. So this is definitely not matched by the agents at the moment yet, unfortunately. So I guess expectations really depend on the use case as well. So if you think about maybe, as Sam said, start small, having an agentic system which actually does like a stress report analysis, for example, I guess there the expectations are pretty well matching also the capabilities. But as long as you go into the more complex world, like systems design, or maybe even like having a full, let's say, RFQ process, for example, there are definitely the expectations which are super high, which most in the cases cannot be matched by the technique at the moment, or only with huge investment. So yeah, recommendation of starting small and then building on top of the others, making sure that the quality is assessed through the process is really critical at this stage, because the technology is super young. And also there's not much to actually rely on, not much, let's say, experience down here at the market, especially in the engineering domain, as this is something which is not very common to the engineering domain yet.
Mm-hmm. So in the end, it's always about, does the technology bring the value that is promised? And Sam, you said we start small. So in the next 1-2 years, where do you see AI agents creating the most value for engineering teams?
Yeah. So, 1 to 2 years. So in that near-term context, I guess I see 3 or so areas where I think that AI agents can really create tangible value for engineering organizations while the technology continues to mature. So first, I would say is in complex documentation processes. So engineers spend a lot of time creating, consuming technical documentation from requirement specifications to test protocols to design justifications. So agents can help analyze these documents, extract key information, identify inconsistencies, and even potentially assist in generating first drafts of these documents. And again, it's not about replacing the engineer's judgment. It's about reducing the amount of time that engineers spend on routine documentation tasks so they can focus on the technical substance of their job. The second is in knowledge transfer and institutional memory. So engineering organizations, like many organizations in the world, face challenges when key team members leave or move between projects or just leave the organization altogether. So I see agents playing a valuable role as knowledge repositories that can be trained on an organization's technical documentation, past designs, maybe even lessons learned. And that creates this persistent institutional memory that new team members can query, for instance. And ideally, that would potentially reduce ramp up time and preserve critical insights as people move around. And third, I would say, which I think is probably the most exciting, also the most complicated, is cross-disciplinary collaboration. So modern engineering challenges increasingly require expertise across multiple domains. So maybe mechanical, electrical, software, and materials engineering, and more. So I think that agents can serve as interfaces between these disciplines, helping translate requirements and constraints between those specialists with different potential vocabularies and concerns and maybe even goals. So I don't think this eliminates the need for cross-functional communication, but it can make it much more efficient by establishing that common understanding more quickly, or being able to, for instance, interact with someone's digital self while they're on vacation for 2 weeks so you don't have to wait for them. So I think what makes these applications really valuable in the near term is that they don't require perfect agent performance to deliver benefits. So they augment rather than replace human engineering judgment, meaning that engineers retain that appropriate oversight over the outputs of the agentic systems while gaining significant efficiency. So as agent capabilities continue to evolve, I think that value proposition is just going to expand. But I think those 3 areas really represent the opportunities for meaningful impact with today's technology over the next couple of years.
Yeah, I mean, a meaningful impact is what we all are thriving for. And talking about what's possible today, Ryan, you just mentioned text to structure, and you talked about different missions that you're already using this for or planning to use it for. Are we truly ready to integrate AI agents into everyday engineering processes? Or is this still a much longer, much more than 1-2 years vision?
Yeah, I think it will be uneven based on, having individuals in certain disciplines, build out the tools like text to structure. So I think it will sort of, you'll find these pockets of folks. Like now we have an optics person and we're working on text to telescope that can, automate design of optics. So I think over the next couple years, it's going to be sort of uneven where you see these happen. But as the broader trend of AI adoption starts to spread, like we have an internal tool that is really taking off, you'll see more interest and it'll really sort of get the ball rolling.
So in all of that, there are many, let's say, steps necessary towards that vision and to manage differing expectations also by the stakeholders involved in these companies, by the stakeholders in the team and the management level. So Ferdinand, what are the risks or challenges in setting these high expectations for the agents?
Yeah. First of all, there are lots of expectations. Because in POCs, we see very nice, impressive, beautiful results. I guess most of all have seen results of a multi-agent system and seeing the conversation of the system, and it looks impressive. But however, to put this on a whole organizational level, it gets much more difficult. And there is this nice picture of an iceberg. I guess, yes, I have Googled it just yesterday. And so it's not a Capgemini invent picture. It's just, yeah, from the web. And you can see as user, you only see the agent and it looks very nice. But there's a lot of homework which have to be done, as I told you before. And therefore, yes, the hype is real. The agents will transform the way we work. I guess the entire discussions we had so far gives us an idea how we can use agents and so on. But we are still only at the beginning. And it's a vision how we can work. But yeah, it's a huge way to go. And furthermore, let's add me an additional comment to Sam's statement. As he told, that it's a possibility to save knowledge. I guess, especially in Western R&D organizations, they will lose a lot of their experts due to retirement. And so all of this you can see here at the picture will help you to save the knowledge and not to lose the knowledge. And then AI agents are the final method to make this knowledge, yeah, usable and feasible.
Mm-hmm. So we have one question that fits in here quite well, because it's about the implementation from Jan, and he's asking, I'm still not entirely clear on what it means to train my agent. How do I teach it? Which parameters or patterns are correct or incorrect? Does this require deep software AI development skills, or can, for example, a PLM consultant with data expertise handle it through a certain UI? Who wants to jump in?
I think I use the word teach, so I'll take it. So typically when I think the place to start usually is in the prompting of the agents. Because if you really think about like what building agentic systems and multi-agent systems is at its core, it's an elaborate prompt engineering structure. And you could put things like, you often use frameworks, for instance, something like LangGraph, where you have a graph-based structure around these agents. You can inject code. But at some fundamental level, the way to, quote unquote, teach agents is often done through prompting. It's an iterative process. Prompting is not an exact science. So I find that I spend a lot of time when building these systems, really trying to focus on the prompts, improving the prompts. Always work with an LLM. That's a big tip that I have. If you're writing agent prompts, there's research out there that shows that LLMs themselves are as good or better than humans at writing the prompts for agents. So always be working with an LLM by your side, in my opinion. But again, that's where you're often teaching things. So before it calls a tool, so you usually have several different prompts you're working with in an agent system. You have the system prompt of the individual agents themselves. You have the prompts that define the tools themselves, so it kind of gives that schematic structure. This is what this tool does. This is when you should use this tool. These are the parameters that go in. These are the parameters that come out. So this is all done usually through text or natural language in prompting structures.
Thanks, Sam.
Maybe I can comment on this as well. So I guess from our side, we try to bring the barrier as low as possible down towards a kind of like a software where also non-experts can use it. But this is like a really like challenging thing, because you want to have like the traceability, no black box approaches. So I think you still need to be some kind of like not an AI expert maybe, but it's definitely some kind of like a maybe prompt engineering expert, Sam, as you said it, or at least like somebody who knows what it does, because otherwise these agentic systems are getting super complicated and also like looping in stuff forever. And so you will have like just a complex system which you're not knowing what it does, and you will end up with a very expensive nonsense. So it's really, really difficult to make these systems reliable and also traceability. And yeah, so it's a process, but you definitely can learn it. And the good thing is, most of us, or basically all of us, are new to this topic. So there's no 10 years expertise out there or studies that you can have taken. So everybody is in a pole position to get an expert in multi-agent systems at the moment, which is kind of really interesting for all of us.
Which is also quite a good answer already to the question of Arno. So where's the data Bible? What is right or wrong? And especially to the same language usage. Do you want to elaborate, Moritz?
The data Bible, what's wrong and what's especially the same language. So, yeah, I guess there's no real data Bible at the moment. What's wrong and what's not wrong. I guess it's an iterative approach. So what we try to do is we start actually with kind of taking the fundamental ground truth of what engineers doing at the moment on like a classical human-based manual level and using the data, and then compare the agent output to the status quo of the real engineers. So this gives us some kind of like a reference point where you can actually see if something is right or wrong, or if the agents take longer than the humans. And then we kind of try to tweak the system until a point where it's actually, let's say, either overachieve or being faster or adding any additional value to the humans or just automating it. But it's like an iterative try and error approach at the moment. So I've already heard some folks going out there with having agents, optimizing agents themselves. So think about maybe a QA agent, which actually oversees the agentic system to have like a self-improving system. So I think this is where like we will see the technology going in the future, self-learning or self-improving systems. But until then, it's just try and error.
And that is already going much into Jan Rikus's question, because he asks, do you see possibilities to assess or verify the AI agent work's quality? How often I do not find the answer prompting quality to be high enough for direct usage.
Yeah, I can take that question. So yeah, that's a really important question. And one of the things that ways that you can leverage your institutional knowledge to give you an advantage in agents is, if you work in a certain area, like I work in space structures, we have the data set that we can go back and compare. So you have to have some way of validating. And that validation could be the way you validate things today, the way you make sure humans don't make mistakes. So, in our work, we have design reviews, or we have various kinds of tests that we put things through. You can put things through the same test to validate the solutions. But the other thing that you probably want to do is build up a data set of examples. So like for structures, we have a set of different structural problems that we can test against. So whatever your industry is, have that test data set, and building that test data set is one of the sort of more challenging and valuable things you can do.
Thanks, Ryan. So Sam earlier used the word elaborate when he talked about multi-agent system and how to build them. And we also just heard Moritz talking about an iterative process, and we are in this together to discover it. So complexity often comes with risks. Seeing these risks and seeing these challenges, what could make it worth it?
Maybe from my perspective, the upside potential is insanely huge. I mean, we have for the first time, we actually have a technology at hand which is able to automate human decision-making, human intelligence, not only like the tools. So this fundamental shift in automation capabilities is just too big to not be at least explored. And of course, it's like a risk at the moment, unexpected expectations, technology risks, and the technology maturing. But just like not trying it, not evaluating it, not like proving it if there is a value, is just like something which you cannot do at the moment if you are a decision maker. So there's basically no way around not trying this thing out.
But all of this and trying things out comes with a huge cost, and the cost, I think, is one of the main topics also in this webinar, as we want to break the cost scale barrier. Ferdinand, in your consultancy expertise, what are you hearing about this aspect?
Yes, I think cost saving is one of the big expectations. But currently the focus is not in cost saving, because that's in an operational, that's on an operation level. I think currently at the POC status, The focus is more on technical feasibility, potential use, and so on, to get the knowledge about the technology and to know how to use it to limit your risks. And so cost is one of the big expectations, but not the current driver. Or it's a driver, but it's not the current tasks or the current thing you have to think about.
Mm-hmm. How do the others see that?
Yeah, I think I can talk about it a little bit from our perspective. We're in a little bit more of a unique situation where we don't make the same car over and over again. When we make a Hubble, we make a Hubble Space Telescope, we make one. James Webb Telescope, we make one. So we're constantly doing non-recurring engineering. It's much different than a lot of our organizations. So I think we can immediately start to see benefits because we are designing 1,000 different parts, unique parts at once. So any kind of even say you make a 20% improvement, that's a pretty big improvement, but we're seeing much bigger improvements like that. So I think it's pretty easy to show the return on investment really with AI in general, because the inference costs are relatively cheap, but then the cost savings that you get with people's time is absolutely massive.
Mm-hmm. So a question for Sam, looking beyond these immediate applications and the costs and all of that, what research challenges need to be solved for AI agents to reach their full potential in engineering? And we've talked a lot about this huge potential that they have.
Oh, I love this question because, at my heart of hearts, I'm a research scientist, so I love the research aspects, where this field is going. I would say I have a handful of ones I'll discuss. I'm going to start off first with verification and validation. I think it connects well to the question from the audience earlier about how can you understand the outputs. I do think it remains a fundamental challenge that we will spend a lot of time working on. So, like, especially in engineering contexts where decisions have safety implications. So we need better methods to ensure that agent recommendations are reliable, are grounded in engineering reality. So current approaches often rely on extensive human verification. I think that's a great place to start, is by using your human expertise. I believe Ryan kind of said this. Leverage your human expertise to understand the outputs of the system. Start to document those. Create a small test set of things that will work. I do think, though, that approach ultimately does limit scalability and efficiency. So we're going to have to start developing frameworks that can automatically validate agent outputs against things like physical laws, engineering standards, and design constraints. And I think that's going to be really important. Is solving, again, I come from a simulation background. So when you're trying to do, for instance, a wave propagation simulation for seismic waves, you do verification steps, you try to get the system to solve something with an analytical solution that you can match exactly, and you do validation, where you do have some data, real world data, that you're trying to match the system against. So again, first and foremost is being able to have that trustworthiness, verification, and validation of your systems. Another, I would say, is that we need advances in how agents understand and reason about physical systems. So current foundation models that we're often working with, large language models, often primarily trained on text data, and LLMs usually form the brains of modern agents as we see them. They don't have to. They can be any kind of AI model, but the modern concept is around using LLMs as the brains. But those foundation models don't necessarily convey an understanding of physical constraints or engineering principles. So an agent might suggest a design modification that looks reasonable in language, but violates basic physics. So research where we integrate these physical simulation capabilities with language models could help us bridge this gap. And that'll allow agents to potentially develop better intuition about the physical world that it's reasoning around. Third, I would say, as we move towards this really exciting world of multi-agent systems, I think we need to better understand how to mimic specific collaborative processes within organizations. So this is really more of a people and human matching problem. So different engineering teams have different ways of working together. I'm sure each engineering organization in the world has your own unique way of working together, your own terminology, handoff procedures, decision processes, etc. So I think the challenge is to create generic collaboration mechanisms that can be widely applicable, but also being able to develop systems that could be tailored directly to how individual organizations, experts work together. So I think this organizational specificity is really critical for adoption and efficacy. Another research area would be memory. So memory and learning capabilities need significant advancement. So current agents have really a limited ability to retain information across sessions or learn from past experiences. So there's a lot of research and very active development into both short-term memory, which is like maintaining context within an individual session that you're working with an agent, and long-term memory, which is retaining knowledge across projects, across time, potentially being able to draw inferences, higher level inferences from sets of observations and memories. I think that's going to be really essential, especially connecting back to talking about institutional knowledge and people leaving organizations in the future. So I think we need agents that can remember previous design decisions, for instance, understand why certain approaches failed in the past, and we can start building those institutional knowledge over time, just as experienced engineers and organizations do. So this is going to require advances in how we structure, store, retrieve memories for agents in ways that are both efficient and contextually relevant. And finally, I would say we're also going to need more research and explainability. So engineers are going to need to be able to understand not just what agents recommend, but why. So I think developing methods that really make agent reasoning more transparent and traceable is going to be essential for building trust and, enabling effective human oversight of these processes. And I'll wrap up by just getting a little plug. If you're really interested in kind of the cutting edge research on some of these topics in the world, I will say that keep a lookout. There's, Synera in collaboration with myself we're putting out a blog in the coming weeks on the AWS High Performance Computing channel on a multi-agent system that we developed together. It's really, really neat. If you're interested in these topics, I would definitely keep a lookout on that blog channel, like I said, over the next couple of weeks, if you're interested in a deeper dive into a real world use case.
I like the drop of that teaser. Definitely have a look out for that. I've read it and it's chef's kiss. Our time is coming to an end. I think there's a very nice ending question by Jan Rikus. Are we facing towards a kind of dystopian scenario in engineering fields like in the Matrix? And how long does it take for AI agents to take over?
I think it's very, it's very hard to predict what's, out past, say, 5-ish years. But I will say this, most of the people that are building AI systems are software folks, or maybe they're physicists. But, the folks on this call, and probably a lot of people in the audience, we're hardware people that know how to build things. And I think it's up to us to try to make that connection between AI and building real things so that we can have a future of abundance.
I think especially the complexity in our field, Ryan, as you mentioned, hardware development, it's different from other domains, definitely. That's also why the software tools have been there for over decades in this old-fashioned way as they are today. So I don't think actually this will be happening, the Matrix, in the next maybe 1 or 2 years. So I would go more like a 5 to 10 years window if I would like to predict something. But I'm definitely looking forward to this moment where we have this kind of dystopian scenarios as engineers working hand in hand with agents, because then we can be so much more innovative and going faster with hardware development as we do today. And this will be amazing, not only for the planet, but I guess also for us as engineers.
I completely agree. I think your vision of a Jarvis is exactly what it should be. So AI agents can help us or can do the recurring task for us, and we as engineer can focus on the very innovative tasks, and that should be our vision.
Great last words, Ferdinand. Thanks a lot to all of our speakers. Thanks for being open to spread your expertise, for There's even extremely strategic topics for many organizations right now. Our audience, thanks for your interest. We'll send a follow-up email to all of you that will include a recording and the LinkedIn profiles of our speakers. Feel free to connect, to get in contact with them, to start some discussions or some philosophical discussions of the dystopian or utopian scenarios that may be in the future for us. You can find us on LinkedIn or subscribe to our newsletter to get the invitations for our next events or to get pinged once the AWS blog goes live. Highly recommend it. Thank you all for joining this session and see you soon. Goodbye.